Hello, everybody. My name's Ben, and I'm going to tell you about how thin films are currently used to 3D print your electronic devices. So everybody owns a smartphone or a tablet or a personal computer, Samsung smart fridge, a device of some type. Now, one of the components that's responsible for making these devices work is called the transistor. A transistor is basically just a switch that controls the flow of electricity. It can either be open or closed, on or off, 1 or a 0. It's like a gate that is open or closed under certain conditions. And a transistor is made of a couple of different materials with different insulating and conducting properties. And it's just the combination of these different materials that enables the transistor to act as this switch or this gate. So the more we can control the flow of electricity, the more 1s or 0s we have, the more powerful our devices are. Now, the number of transistors isn't the only measure of the power of a device, but it's a pretty good metric or rule of thumb to go by. So modern chips contain over 1 billion transistors. Now, they cram 1 billion of these tiny devices into an area of a couple square inches. So how exactly do they do that? They're not going in there and manufacturing each transistor by itself. That would take forever. So the answer as to how this is done is it's done using thin film deposition, and it's done all at once, all at the same time. So these billion transistors are being manufactured concurrently. So thin film deposition is an additive process, meaning we're starting with basically nothing, and we're building up layer by layer to get what we want. So this usually starts in the gas phase. The chemical precursor containing the material that we want to deposit is sent towards our substrate as a gas. And then we initiate a chemical reaction with this precursor. This can be an increased temperature, decreased temperature, the introduction of another chemical. It can be any number of things. But the point is, we get a chemical reaction, and the material that we want is deposited on our substrate. So recall the picture of the transistor from earlier. This is a 3-dimensional object with several different types of materials. So how is thin film deposition going to help us achieve this? Well, here's a picture of the same transistor in profile, or just from the side. So I'm going to try and demonstrate to you how thin films can be used to make a 3-dimensional object. So like before, we start with our substrate, and we deposit our first material from the gas phase again. Well, this doesn't really get us anywhere. It's just a single layer of material. But what we can do with thin films is that we can use other subtractive processes like chemical etching to pattern these into simple geometric shapes. So now we're kind of getting somewhere. We've patterned our first material. So now we can deposit another material on top of that, again, probably from the gas phase. But since this material is different, we can etch it away using a different chemical that won't harm our first layer underneath. So we can pattern it into something different. And we can actually do this over and over again with different materials to eventually build up the shape that we want and to pattern them. So we eventually end up with a 3-dimensional device that has the functionality we desire. So, and remember, we're not just making one transistor at a time. This patterning and layering technique we can expand to, any number of transistors. So we're actually making a lot of them, a lot, at the same time. We got to get those billion transistors, remember. Now, this is an example of a thin film deposition going on. And that purple glow is a plasma. And so our chemical precursor is in the gas phase. That plasma is initiating the chemical reaction, and that material is depositing on our substrate. It's just an example of something that's used in industry. So in actuality, there's hundreds of steps needed to achieve the building of a transistor or other devices. I just showed you kind of a simple mock-up, but the principle remains the same. We deposit thin layers of material, pattern it, and build on top of that until we get our 3D structure of the device we want. So with that, I hope you guys have learned a little bit about how electronic devices are manufactured. and thank you for listening.